Hello, my name is Emma Smith and I'm a 10th grader at Quaker Valley High School. Today I will be presenting In Salted Plants, the effects of salinity on freshwater plants. Next slide. My interest in all aquatic life in the environment has increased throughout high school due to my recent participation in different environmental internships. I recently became interested in the watershed and the waterways around me. One creek in my community that has been a big part of my life is Little Swickley Creek. This creek is known for being very healthy, but has recently been found with a high conductivity level. With the Quaker Valley High School Creekers internship, I learned about conductivity and then started to research salinity levels and their effects. I'm interested in how humans affect the environment, such as the use of rock salt in the winter, and I'm very concerned about how rock salt near our waterways can negatively affect aquatic life. Next slide. The problem I'm trying to solve is how does the amount of salinity affect the growth of a freshwater plant? Next slide. The Lodia canadensis is a freshwater plant that belongs to the Hydrocertaceae family of plants. This group of plants are native to both North and South America and are known for being a very hardy plant. The environment affects plant growth and health. If the plants are surrounded by bad environments, plants would have a hard time surviving. All plants have a semi-permeable membrane which allows water to move in and out of the plant cells. Plants also have a cell wall which keeps the plant upright and sturdy. The vacuole in a plant cell holds water and other nutrients. The vacuole can also affect how sturdy the plant is and affect the cell wall too. Siderosis is the permanent collapse of the cell wall due to too much water being lost in the vacuole. Next slide. Increased salinity can affect the growth of a plant directly and indirectly. The salinity effect is when decreased water intake causes a plant to use more energy to absorb water. When plants are put into extremely salty water, the water moves in and out of the plant cell, which causes the central vacuole to shrink and expand. Plasmolysis is a contraction of the protoplast of a cell wall. When the protoplast contracts, there is a loss of water from the cell. During plasmolysis, the cell membrane pulls away from the cell wall, causing the plant to shrivel and become flaccid. Plasmolysis occurs due to high concentrations of salt outside the cell, which causes the diffusion of water from within the cell to move outside the cell. Concave plasmolysis is the shrinkage of the cell wall which can be reversed. Convex plasmolysis, however, is when the plasma membrane and protoplast completely detach from the cell wall and cannot be reversed. Next slide. My hypothesis states if the freshwater plant Alodia is exposed to 5 different salinity levels, then I predict salinity will have a negative effect on the growth and development of the plant. Next slide. On this slide, I have pictures of all the materials I used. I use these materials to build different components of my experiment. Next slide. Here are pictures of me putting together things for my experiment. For the experiment, I had to make 5 different lighthouses to hold my plants. I made 5 different aquatic environments for each of the 5 groups of plants, and I had to learn how to use a refractometer, which told me how much salinity was in the water. Next slide. Here is data table 1, which shows my experimental parameters. The independent variable for my experiment is the amount of salt in spring water. The 5 different levels of salinity are 7.3933, 14.7868, 22.1801, 29.5735 milliliters of salt, and no salt, which is also my control group. The independent variable of the experiment is the amount of growth and changes in the Alodia plant. These growths and changes were measured through both quantitative and qualitative measurements, which were measured in centimeters. There were also many controlled variables in the experiment, such as the type of plant used, the temperature of the water, the wattage of bulb used. Next slide. Here is data table 2, which shows the average height of the 4 plants housed in the lighthouses with different levels of salt, and 1 lighthouse with no salt shown by growth per day. In Lighthouse 1, the plants were in the water with a salinity level of 0 ppm. Lighthouse 2 has a salinity level of 4 ppm. Lighthouse 3 has a salinity level of 8 ppm. Lighthouse 4 had a salinity level of 10 ppm. And Lighthouse 5 had a salinity level of 13 ppm. ppm is the measurement of parts per million and changes based on the amount of salt in the water. The more salt, the higher the salinity level. Next slide. These are pictures of plants in Lighthouse 1, which has a measurement of 0 ppm of salinity from days 1 through 9. Next slide. These are pictures of plants in Lighthouse 1 on days 1 through 14. Next slide. These are pictures of plants in Lighthouse 2, which has a measurement of 4 ppm on salinity from days 1 through 9. Next slide. These are pictures of the plants in Lighthouse 2 from days 11 through 14. Next slide. These are the pictures of plants in Lighthouse 4, which has a measurement of Lighthouse 3, which has a measurement of 8 ppm of salinity from days 1 through 9. Next slide. These are pictures of the plants in Lighthouse 3, which from days 11 through 14. Next slide. These are pictures of plants in Lighthouse 4, which has a measurement of 10 ppm of salinity from days 1 through 9. Next slide. These are pictures of plants in Lighthouse 4, which has a measurement of 10 ppm salinity from days 11 to 14. Next slide. These are pictures of plants in Lighthouse 5, which has a measurement of 13 ppm salinity from days 1 through 9. Next slide. These are pictures of plants in Lighthouse 5 from days 11 to 14. Next slide. Graph number 1 shows the height of plants in aquatic habitats with different levels of salinity by growth per day. Next slide. From graph 1, you can see there's a direct correlation between the level of salinity and plant growth. The higher the amount of salinity, the larger the decrease in plant growth. At the beginning of the experiment, all the plants measured 20 centimeters in length, and all the plant cells looked the same through a microscope. The plants in Lighthouse 1 with a salinity level of 0 ppm experienced little change other than on day 11 when the plants began to drop roots. This showed the plants were in a healthy environment. The plants in Lighthouse 2 appeared healthy through the whole experiment with very little change until the last days of the experiment. On days 13 and 14, the plant leaves started to wilt with some fade in color. These plants went through concave plasmolysis, which is a less drastic form of plasmolysis that can be reversed if the plants were to be put back in their natural habitat. You can tell the plants went through this type of plasmolysis by looking in the microscope for day 14, where you can see that there's no change in cell structure. The plants in Lighthouse 3 began to wilt noticeably by day 7. At this point, the plant stems were weakening due to plasmolysis, and the plant cell walls were starting to weaken and turn brown, which can be seen in the microscope pictures of the plant on day 7 and on. By day 11, the plants began to wilt and the leaves have faded in color while becoming puffy in appearance. The plants became puffy due to taking in large quantities of salt, which caused water to build up in the plant. This is called plant edema. Also, the plant's height went from 20 centimeters to 12 centimeters, which is a 40% decrease in height, as seen in data table 2. This decrease in height happened because of the weakening plant stems. The plants in Lighthouse 4 started to wilt by day 3, which is much earlier than other plants. By day 9, as seen in data table 2, there was an 8 centimeter height difference, and by day 14, the plant was only standing at 5 centimeters tall due to the plant stems being so weak. This was a 75% decrease in height. On day 7, I began to see that the plant started to brown in the stem and the leaves had started to become noticeably puffy. Both traits only got worse. The plant leaves in Lighthouse 4 became purple as seen in microscope pictures on day 7 and 9, which was unique to only this plant. This color change in the plant leaf is due to macronutrient problems from the salt water. The plant in Lighthouse 5 seemed to be in such a large amount of salt water that it instantly started to kill the plant rather than go through the phase of losing macronutrients. By day 3, the plant had already started to become translucent in color, and the leaves of this plant also went through plant edema. Lighthouse 5 also went through convex plasmolysis. Since the plant went through convex plasmolysis, which leads to the plant cells while caving in on itself, by day 9 the plants were completely falling over, and on day 11 the plant's stems were disintegrating at the touch. In Lighthouse 4 and 5, there is a drastic change in not only the height of the plants by the end of the experiment, but also in how the plant cell structure looked through the microscope. The plants were both exhibiting changes by day 5, which included the change in color of plants, and the cell walls seemed to be collapsing rather than looking like rectangles as seen in the first days of the experiment. On day 5, both of these plant leaves had started to change color and fall apart. Next slide. My hypothesis was proven correct because salinity had an effect on the growth of the freshwater plants, and that the lighthouse with the highest salinity, lighthouse number 5, was negatively affected and the plants were negatively affected. Understanding how salt negatively affects freshwater environments could change how people use rock salt. Since many communities use rock salt during the winter, people could aim to use a substitute that is more environmentally friendly. My experiment could be used to educate people on how their actions impact streams, waterways, and watersheds around them. Lastly, my experiment shows the effects of salinity on freshwater plants. Next slide. Here's my bibliography of the sources I use. That concludes my presentation, and thank you for your time.